Welcome, dear students. Before the Onam holidays, so in the last lectures, we started discussing about DFT. So, I hope you remember what is DFT, discrete Fourier transform, and how it is being related to DTFT. So, in today's class, what we will do is we will see how to compute the DFT using Matlab. Okay, so you can directly implement the algorithm for DFT using the expression that we have derived. That also can be done. There is a much easier method in Matlab to compute the DFT, and that is by using an algorithm called as FFT, fast Fourier transform. So we will study about fast Fourier transform later, and we will implement or we will try to compute the DFT of a given signal using the FFT function that is already available in Matlab. So I have opened the uh, MATLAB panel, and you are familiar with this panel since you have done it in Systems and Control Lab. So the command that I am using to compute DFT is called as FFT. So I'll write help FFT to see what are the arguments for FFT. So FFT is discrete Fourier transform, and FFTX is the discrete Fourier transform of vector x. So if you give a vector, and FFTX gives the discrete Fourier transform, and so on. And let's look at this. So FFTX comma n is the endpoint FFT padded with zeros if x has less than n points and truncated if it has more. So we have studied about endpoint DFT, right? And also we have studied about zero pad. So this is the format that we are going to use, FFT x comma n, where x is the vector of the discrete signal and n is the capital N in endpoint DFT. Okay, fine. So let me clear this. So what we will do is we will write the program for the exercises that I have given as example. So I have given 4 questions. Out of this, 3 questions are to compute the FFT. We will do the second question as a sample, and you can try out the remaining questions. So the second question is compute the 4-point DFT of the sequence x of n is equal to 1, j, minus 1 and minus j. Okay, so in order to do that, we will take a new program, new M file. So I'm going to new and selecting the script. So whatever I am showing here, you can do in the online MATLAB also. Okay, you can create an account in mathworks.com using the TKMC email ID and go to matlab.mathworks.com and sign in using that particular login ID and password. And in that you can do this same thing what I am showing in MATLAB. Okay, so this is the new M file that I have created in which I will be writing the program, and you can see the response in command window. So let me save this. So I am going to save this by the name. You can save it by any name. So let me name it as DFT computation. Okay, so for starting any program, clear and CLC command need to be given. Clear command is to clear the workspace, and CLC command is to clean up the command window so that you can write the or you can run the program in a clear command window. So the question is compute the 4-point DFT of the sequence x of n is equal to 1, j, minus 1 and minus j. Okay, so we know that the command that we need to use is FFT, and the variables are, you can give any variable. So let me name it as x comma capital N. Okay, now I need to define x and n. What is x? X equal to, x is the input discrete signal. It is 1, j or I, you can use any of those, minus 1 and minus I. Okay, so I have inputted the discrete signal x equal to 1, j, minus 1 and minus j, and you can input n. What is n here? You need the 4-point DFT. So x equal to 1j minus 1 and minus j, n equal to 4, and f of t x comma n computes the DFT of the discrete signal x with n point DFT. So let me name this as DFT DFT of x, DFT underscore x equal to f of t x comma n. So let me run this by pressing the run button and see in the command window what is happening. Okay, so when I press the run button, you can see that the x is defined. It is 1 plus 0i, 0 plus 1i, which corresponds to j, uh, minus 1 plus 0i, and 0 minus 1i corresponds to minus j. So let me use I instead of j so that it will be consistent. Now let me run it. Okay, so the x is 1, I, minus 1 and minus I, n equal to 4, and you obtain the DFT as 0, 4, 0, 0. So if you have worked it out, you will get this particular answer. So this is the easiest way to compute the DFT. Now the next question is how to plot the frequency spectrum. Okay, so in order to plot the frequency spectrum, what you need is, you need the magnitude as well as the angle of the DFT signal, right? So in order to get the magnitude, you can use the command absolute ABS. Okay, so ABS, so let me write ABS here. So ABS DFT underscore x, it gives the magnitude value, and the command phase DFT underscore x gives the phase value. Here the phase is 0 because there is no complex nerve, and the magnitude is 0, 4, 0, 0. So these two commands gives the magnitude as well as phase. So let me incorporate those in the M file. So let me give the name magnitude underscore uh, DFT x is equal to ABS DFT underscore x. So ABS gives the absolute value of this DFT, and that is being stored in a variable name magnitude underscore DFTX. And uh, in order to get the phase, let me give phase underscore DFTX equal to the command phase DFT underscore x. Okay, now let me run this. So you can see that you have obtained the magnitude value as well as the phase value. Now how to plot it? So in order to plot the magnitude and phase value, you need a command called as stem, STEM. Okay, so the discrete values are plotted using the stem command, and for continuous values you can use the plot command. If you have used stem command, you know what is the difference. So I'll show how to use the stem command. Now in order to use the stem command, you need the x as well as the y. So let me try to plot the magnitude plot using stem command. So in order to do that, I need to define one more variable which corresponds to the x-axis. So let me define it as w, which is varying from 0 to 0 with a instance of 1 till n minus 1, because I need what, I need four instances in the x-axis, right? 0, 1, 2 and 3. That is why I have given 0 to n minus 1. So that means 0 to 3 with 1 as the difference between each instant. So W is 0, 1, 2 and 3. So I'll run and show you what is W. See, W is 0, 1, 2 and 3. Now I can float using the stem command. Stem W, comma, magnitude underscore DFT x. So let me try to run this. Okay, so you got the magnitude spectrum. So at 0 it is 0. So if you look at the magnitude, it is 0, 4, 0, 0. At instant 0 it is 0. At instant 1 it is 4. At instant 2 it is 0. At instant 3 it is 0. Right? So similarly, you can plot the which one? You can plot the phase spectrum as well. For that, stem W comma phase underscore DFT x, and if you run it, you will obtain the phase which is all 0 at all those 4 instances. Now suppose you want these two plots in same command or same window. What you need to do is you need to use subflow. So you need to use subfloat 2 comma 1 comma 1. If you know what is subfloat, you can use that. So I'll just briefly describe what is subfloat. So in using I'll first run and I will show you what is happening. So I'll run it. So you can see that there are two plots. So in subplots you can plot one after another in same window itself. So here I have defined it as subplot 2 comma 1 comma 1. What does that mean? 2 comma 1 means the first two elements, it corresponds to how many figures you want. Right? Here I need two figures, one below the other. It's like a 2 by 1 matrix, right? So if it is 2 by 2, then it corresponds to, if I am putting it as 2 comma 2, it means that I need 4 plots in a subplot. Okay, so let me put it as 2 comma 2 for the moment. In both I have changed it to 2 comma 2. Then you can see that it understands that there are 4 figures. Okay, so let me put back 2 comma 1. So that is subplot. So the first two indicates that what is the number of plots, and the third one indicates in which position. Okay, so 2 comma 1 means it can be either the top or bottom. So 2 comma 1 means the magnitude plot, which is this plot, comes above, and 2 comma 1 comma 2 is, this means that the phase plot comes below. If I put 2 here and if I put 1 here, what will happen is the phase plot will come above and the magnitude plot will come below. See. So that is about subplot. So let me keep it as the original one, 1 and 2. Okay, so this is the way to plot the frequency spectrum of DFT. Okay, so you need to define the signal X, and you need to define what is the capital N or for the endpoint DFT, and you just need to use this particular command FFT, which is basically fast Fourier transform, which you will study later in this particular module. And In order to compute the magnitude, you can use the command abs. In order to compute the phase, you can use the command phase. And you need to define the x-axis, and using the stem command you can plot the frequency, magnitude and frequency plot. Now you can put more colors to this, like you can define the legends, you can define the x-axis, y-axis and so on, so that this looks neater. So I am leaving that for you. Now let me try to do the next problem also. The question 3 is compute the 8-point DFT of the sequence x of n is equal to 1111100 and plot the frequency. So what changes I need to bring? So I need to change x need to be 11111100, and what is capital N? N must be 8, right? Now the rest of the things are the same. Now if I run, so this is the phase of the magnitude plot as well as the phase plot, correct? So so you can do likewise. Now let me show you how to obtain the inverse DFT. So in order to obtain the inverse DFT, what you can do is you can use the command IFFT. So let me show you what is IFFT. Sorry, write help IFFT. Okay, so IFFT is inverse discrete Fourier transform, and IFFTX is the inverse discrete Fourier transform of x, and IFFT x comma n is the n point inverse discrete Fourier transform. So we can just use this particular command to get the inverse discrete Fourier transform. So let me try in this example itself. So using this particular command, I have computed the FFT of this signal, and now let me try to find the inverse DFT. So inverse DFT is equal to IFFT, and uh, what is the input argument? Input argument is the DFT underscore x. So what I am doing is I have found out the DFT from x. Now I am trying to get x from the DFT signal. Okay. So the DFT obtained is DFT underscore x. I am giving that as argument to this IFFT, and I am looking for what is this thing. What I expect is inverse DFT must be equal to this x 11111100, right? So let me try to run this. So you can see that I have obtained the inverse DFT as 11111100. So you can use the command FFT to find the DFT of the signal, and you can use the command IFFT to obtain the inverse discrete Fourier transform, or to find the discrete signal corresponding to the DFT signal. Okay. So now what I would suggest is uh, I will show you what I want. So this is a program that I have written, and okay, so I have given an input signal of 1 by 5, 1 by 5, 0, 1 by 5, and I have given 3 n's. N for first case it is 16, another case it is 32, another case is 64. And for these 3 n's, or the first one corresponds to 16-point DFT, second one is 32-point DFT, third one is 64-point DFT. So for these 3 cases, I have plotted the frequency spectrum, right? So what I want you to do is you have to similarly find the DFT of 16 point, 32 point, and 64 point DFTs of these two examples that I have done. For example, the exercise 2 question and exercise 3 question. Okay, so please try out the 16 point DFT, 32 point DFT, and 64 point DFT of the signals xn equal to 1 j minus 1 and j, as well as the signal 1 1 1 1 1 1 0 0. Okay, and also find the inverse also, and you can see how the signal and DFT are related to, or one signal corresponds to the DFT, and so you can see the relation. Okay, so please do it. I'm doing this video because I understand that you are having a lot of placement training going on, so you want the data to be kept for that particular thing. So I won't be taking too much of data for the class. So you can use this particular video to understand and do this exercise. So for tomorrow's class, I'll just log in and see this result. You need to show me this particular result in your computer. I'll call randomly. You need to show me this result, and I will take the attendance in that time. Okay. So I hope it is clear. So I want you to be familiar with what is DFT and you what is IDFT, and we will do more problems in the coming classes. Okay. Thank you.